Welcome to Intermediate Algebra, Unit 4, Lesson 3, Solving Systems of Equations Using Elimination. In our last lesson, we looked at solving systems of equations using substitution. That works really well when you can isolate one variable, but this method of elimination will help us in the situations where we don't have one variable that's easily isolated. So our objective is to use the method of elimination, which is also called linear combination, to find the solutions to a two-variable linear system of equations. And this is what I just said. Substitution works really well. It works well even when you have fractions, but students don't typically like to work with fractions. So if you can easily isolate the x or the y just by moving some things around on different sides of the equation, that's easy to use. But elimination may be easier in many cases. So when we say linear combination, like you see at the bottom of the slide here, what we mean is you're multiplying an equation by a number and multiplying another equation by a number and then adding them together to combine them. Linear meaning you're multiplying by constant. So some basic principles to keep in mind. If you have an equation, then you can multiply each term on both sides by the same factor and still have a true equation. So for example, if you have 3x minus 5y equals 4, if I multiply everything in that equation by 2, each term, I get 6x minus 10y equals 8. That is still true because I've done the same thing to both sides, but it is essentially the same equation. It tells me the same relationship. It would be the same line if I graphed it. Or I could multiply everything by a negative 1. So I start out with this 3x minus 5y equals 4. Multiplying by a negative 1, I get a negative 3x plus a 5y equals negative 4. Multiplying by a negative 1 changes the sign and everything. But if I multiply everything on the left by negative 1, I must also multiply everything on the right by negative 1. So this principle is applied to put whatever system of equations we're giving into a form that will allow us to add them together and have one of the variables drop out. So you multiply an equation by something that will give you the opposite value of y as you have in the other equation. And then when you add them together, you'll be able to solve. And we'll see this on the next slide. So to solve this system, I make some observations, and the first thing you should do when you get a problem is take a look at it, see what things you notice. So I noticed that the top equation subtracts 4y and the bottom equation adds 4y. Well, if I combined a negative 4y, remember subtracting is like adding a negative, so basically the top equation adds a negative 4y. If I combine the negative 4y in the 4y in the two equations, I would have my y's go away. So that's the pattern you're looking for. That's the first pattern you're looking for. If you have that, you won't have to make any other modifications to your equations before you start eliminating. So we have a rule of algebra that says if I have 2x plus 4y equals, if I have 3x minus 4y equals 5, I can add 10 to both sides of that, and I still have a true statement. So that would be 3x minus 4y plus 10 equals 15. Well, that's true, and we've known that for a while, but it doesn't really help us here. But what does help us is the fact that this second equation says 2x plus 4y has the same value as 10. So instead of adding a 10 on this side, I can add 10 in the form of 2x plus 4y because they are the same value. So what this means is that to the side with the numbers of my first equation, I'm going to add the side with the numbers to the second equation. To the side with the letters, I'm going to add the side with the letters. This is legal because the second equation tells me adding 10 is the same as adding 2x plus 4y. So you line up your variables, and you have to make sure you line up. You don't want to accidentally add your x's with your y's. And I add the two equations. So when I add the two equations, I have the 3x plus the 2x gives me the 5x. The negative 4y added to the positive 4y gives me a 0, and that just goes away. I don't need to regard that when I'm finishing my solution. So 5x equals 15 is what I'm left with. I divide both sides by 5, and I get x equals 3. And just like in substitution, we're not done. We've only got half the answer. We need an x and a y. And also, just like in substitution, we can go back to one of our equations, put in the x value we just found, and solve for y. And then we can check it by using the other equation. So I put x equals 3 back into the top equation. And you can see the 3 right here. And that gives me 9 minus 4y is 5. I subtract 9 from both sides. Negative 4y is negative 4. I divide both sides by a negative 1. And I get y is 1. That's not true. I get y. I'm sorry, I divide by negative 4. And I get y is 1. Why am I dividing by a negative 1? If I divide by negative 4, which I should have divided by, I get y is 1. I was thinking, no, I checked this on the next slide. So I find x, plug it into one of the equations, find y, and then to check my work, I use the top equation to find y, so I'll use the bottom equation to check. I put in my values for x and y. There's my 3 for x, there's my 1 for y, and I do get a true statement. So since 10 equals 10 is true, my solutions are correct. So here's a second example. Now, this one, the observation you make is adding the two sides of the variables will not get rid of either variable. I'd end up with a 3x minus 4y. So you look for some other things. If I multiply the bottom equation, the second equation, by negative 2, that'll give me a negative 2x as the first term. And then if I add that to the top equation, the x's will go away, which is goal, which is why we call this elimination. We're eliminating one variable to find the other. So I multiply each term of both sides of the second equation by negative 2, and that goes back to what I said in one of the very beginning slides, is I still have a true statement, and it still really represents the same relationship. So when I do that, I get a negative 2 times 1 becomes negative 2x plus 6y equals 6. So I multiplied that bottom equation by negative 2, and that becomes my new second equation. That's now the problem I'm working with. Now I can add the two equations, and I see I get 5y equals 10. And then that gives me y equals 2 when I divide both sides by 5. And so once I have y equals 2, I go back to the top equation, and I see I put my y equals 2 right there. And I solve for x, and I get x equals 3. Now to check my work, I go to the other equation and put in my numbers, and I see that 6 minus 2 equals 4 is true, so my solution is correct. So this one, if I add them together, it feels like I should be able to get rid of the x's, but if I add them together, I get 2x. So some of you are saying, well, I'll just subtract it. You can do that, but I would suggest the way you go about subtraction here is you change that second equation, or the first equation, it doesn't matter, by multiplying each term by a negative 1 and then add, because usually what happens when students subtract is they're very good at subtracting these two, and then they end up just adding for the rest of it. So what I want you to do is transform that second equation so that when you add, you will get the variable falling out. So I multiplied each term by a negative 1. And notice subtraction, these two here together are going to give me a positive. You'll see that in the next slide. And the negative 1 times negative 9 gives me a positive. I know students sometimes struggle with sign number arithmetic. Okay, so now these are the two equations I'm working with. I can forget about what I had before because I've changed this second one. So because I've changed the second one, when I add these, I get a 0 plus 4y, and then there's the 8. So I get 4y equals 8. Divide both sides by 4, and I get y is 2. I need to find x now. I found y first in this case. So, the slide had already gone forward. So y is 2. I substitute into the first equation. So instead of y, I put a 2, so x plus 2 equals negative 1 instead of x plus y equals negative 1. And at the very bottom, you see x equals negative 3. I subtract 2 from both sides to get that. Now to check this, I plug back in, and I'm using the other equation. Negative of a negative 3 is a positive 3, plus 6 equals 9 is true. So my solution is x equals negative 3, y equals 2. Okay, so this is the last type of situation you'll encounter, pretty much, where, it's not simply I have to subtract, or I have to change a negative 1, or I have to multiply one of the equations. In this case, you're going to have to multiply two equations. So, and you have to rearrange the terms. So the first thing you notice is you don't have any order. There's your y, there's your y, there's your x is on the other side here. You have to put these in the correct order before you can do anything with them. So the first thing I did was restate my problem. There's the problem I'm given, and I like to have it in the order with the x's and y's on the left and the numbers on the right. I could do it the other way around. I could put the y's first, but typically x's go first in what we call standard form. So that negative 5x stays there. I added 18 to both sides to put that over there, and I just moved the 7y. So that's how that went on that first equation. And on the second equation, I add 17 to both sides, and that has the effect of putting that over there. I subtract the 4x to get it over to the other side, and that goes over there, and then the 3y just stayed there. So now what I have is a more organized setup of my problem. I haven't done the problem at all. All I've done is restated the problem. But this is the style, the format you want your problem in. You want your variables to be lined up. Now I can see, as I look at what I've circled in blue here, negative 5x, negative 4x, I can't add those and get 0. 7 and 3 is 10. It's not like 2 times 3 would give me 7, and so I can multiply by negative 2. There's no clear way to multiply one equation and make something go away. So you have the option of multiplying both equations by something, and they don't have to be the same thing. The only thing that has to be the same is whatever you multiply the left of the first equation by, you have to multiply the right of the first equation. But you can choose a different value for each equation, so you end up with terms that get eliminated when you combine them. So here's the system we're solving. If I multiply the first equation by 4, so where did I get the 4? Well, there's a 4. In the second, so I'm going to multiply the first equation by 4. And I'm going to multiply the second equation by negative 5. Why aren't they both negative? Why is one negative? Well, these have the same signs. I want to end up with opposite signs. So if they start out with the same signs, one of the equations needs to be multiplied by a negative. If this were a positive 5x in my first problem, I would just multiply by a positive. I would just multiply the bottom by a positive 5. So if you accidentally multiply both by positive, you would see that you ended up with, well, I'll show you in a minute, you would end up with the same term in the front, and you would need to subtract, so then you would multiply by a negative 1. But I want one of those terms is going to be a 20, one is going to be a negative 20. I could have multiplied the first equation by negative 4 and the second by positive 5. It doesn't matter. But I also have to remember to multiply the numbers on the right. That's often forgotten, particularly when you're doing both equations. Students forget that. So here is the multiplication done out. I multiplied this one by a 4. I multiplied this one by a negative 5. And notice I carefully wrote it in front of each term so I wouldn't forget anything. in an effort to be quick, students often make mistakes, so don't try to be quick here. So the equations become this, and you can see now when I add these two together, the x is going to be eliminated. So I add them together, and 28y minus 15y leaves me a 13y. And 13y equals negative 13. The negative 13 came from 72 minus 85. You would do 85 minus 72, but make the answer negative because the bigger number is negative. Working with sign number arithmetic here. So 13y equals negative 13. I divide both sides by 13. I get y is negative 1. I put that back into, I went to the original equation, and that's just in case I made a mistake. Because if I made a mistake and wrote a new problem that wasn't related to the old one here, I wouldn't get the right answer to the original problem. I get the right answer to my mistaken problem. So I go back to the original equation. This was y in the original equation. Negative 5x plus 7y equals 18. You could even go back to the unrearranged form. That would even be more true. More of a check on your work. But I end up with negative 5x equals 25. And I get x equals negative 5. You should be able to go through those algebra steps. Now I want to check my work. I put back into the original second equation, and I see 20 minus 3 is equal to 17, so my answer is true. All right, so here is example 5. Now this one, actually, if I multiply that top equation by negative 2, then I will make the x's go away. So I do that. And what happens when I add the two equations together is the x's and the y's go away, because when I multiplied by a negative 2, I also get a negative 2y, and those combined give me no x's plus no y's equals 0. Well, 0 equals 0. What do I do with that? How do I find it? Doesn't matter. This is a true statement. It's always true. So there are an infinite number of solutions. If these numbers had been different here, if I had had negative 2x minus 2y equals 5, and 2x plus 2y equals negative 2, I would have gotten a 3 here and a 0 here, and that would have been no solution, because that's never true. So if you get a statement that 0 equals 0, and you kind of go, well, that's master of the obvious material, I see that, then it's always true. You have infinite solutions. If you get a statement that's never true, 0 can never be equal to 3, then there's no solution. So here are 4 of these for you to try. I want you to solve these by elimination, and they show all the techniques I've shown here. Try the 4 of these, stop the video, and then come back to check your answers. See, you're back. So here are the answers. If you did not get these, or if you did not get any of these, you need to get help right away. If you have a question on one of them, you can email me. You can always bring your work to the tutoring lab. Bring the guided notes. That's why we have you print them out and have them help you. But you need to straighten this out right away. These techniques will be useful to you all through your math education. That's all for now. Thank you for joining me in this edition of Math Teacher Go, and we will see you next time.